Hey everybody, this is a quick CER review for one of our first CERs of the year. So the review is going to be a little bit more in depth here. So I'm just going to review some of the basic things. So again, this is CER. C stands for claim, E stands for evidence, R stands for reasoning. So we're going to use this in science quite a bit last year. For those of you who are in our school district, you have been really working hard on CERs in sixth grade, seventh grade, and eighth grade. So for the last couple of years. So what we want to do is the claim is, what do you know? So based on the data, based on the evidence that you have, what do you know? The evidence is, how do you know that? So in other words, we have to back the claim up. We can't just make a claim without evidence to back it up. And the reasoning is, why does your evidence support your claim? So it kind of comes through and it highlights the claim of the evidence, say this is why it all fits. And this equals a scientific explanation. So the claim is the shortest part of the test. It's the shortest part of a CER. So if you were taking a test, and you will be taking tests, it only has to be a sentence long. It answers the question, what can you conclude? It should not just simply be a yes or no or start with yes. And I guess technically it could start with yes as long as you come back and you support it with the rest of the statement. And it should describe the relationship between the dependent and independent variables. So here's our practice CER that you went through. So if you're watching this video, you probably either missed it, you were gone that day, or you're going back to review it and using this to help hone your CER skills before the next test. So the question is, which materials would float if placed in water, which has a density of 1 gram per milliliter? So here's your data. When we look at this data, you've got your materials here and you've got your densities here. So what you would need to do is you need to look at this and figure out which ones float. Now, do you know that right offhand from class? And you probably should from our notes, but you could always go back into the notes and use it because these are going to be open notes tests. The other thing you could do is if you flip the page over, if you have the paper copy, if you have the online version, it might be on the first page. But if you look at the scientific principles, and this might be a good tip for you, always look at the scientific principles first. So there's the question again, which material or materials would float if placed in water, which has a density of 1 gram per milliliter? Now you notice number 1 mentions density, so that's a good chance that fits. Density is an unique characteristic that helps identify a substance and distinguish one substance from another. So that's great. It helps you identify. And we're going to do a lab where we do this, where we work on identifying, or we may have already done the lab, the relative density lab, where we use density to help, or relative density to help identify substances. But that's not what you're doing here. You're not identifying substances. You just want to know if it floats or not. Number 2, a substance is made up of only one type of material all the way through. True, but wait, what does this have to do with floating? It doesn't. Now look at 3 here. An object with a density greater than 1 gram per cubic centimeter will sink in fresh water. Okay, that sinks. We want to know float, but read on. An object with a density less than 1 gram per cubic centimeter will float in fresh water. Bingo, because we want to know which material floats. Now I'm going to read the last one just to check it. Properties of a given substance are the same regardless of the amount. Mass and volume. Now mass and volume makes density, but just because we have a bigger rock and it's got the same density, that doesn't have anything to do with whether it'll float or not. So number 3 kind of gives it away. So when we back up to the CER and we're going to write a claim, we already know anything less than 1. So it's going to be ice, oak, and cork. So right here is a good example of a claim. The material that would float if placed in water are ice, oak, and cork. Now notice the question, which materials would float, and how I started out the claim. The materials that would float. Now it says if placed in water, if placed in water. So when you write your claim, you want to have it be thorough. So I would use a lot of the sentence, the question, in your answer. So you don't want to just say ice, oak, and cork. Because my question would be ice, oak, and cork. What? Do they float? Do they sink? And some people would argue, well, it says right here which materials would float. So I said ice, oak, and cork. Well, it's not detailed enough. That would be a developing claim. But this would be a proficient claim. Now, I'm not going to necessarily go into great detail any detail how you can make this advanced, because I want you to try and figure that out, see if you truly are advanced. Evidence. Evidence is what supports your claim. So again, the neat thing about science is you can't just make claims without any evidence. Or you can, but then your claim will be proven wrong. So the evidence, you want to have sufficient evidence. You want to have enough to support your claim, or at least some to support your claim. It needs to be appropriate. In other words, it's supporting the right stuff. Leave out information that doesn't support the claim. Now, it's got to be qualitative using senses, or quantitative. And this is huge. We'll come back to this. Quantitative is you have your data, you have numbers. And that's huge because you can see we have lots of numbers here. And we want to be able to use those in our evidence. So here's what I wrote for the evidence. 3 substances have a density that is lower than that of water, which is 1 gram per milliliter. Ice has a density of 0.9 gram per cubic centimeter. Oak has a density of 0.6 grams per cubic centimeter. And cork has a density of 0.1 gram per cubic centimeter. All other substances have densities greater than that of water. So notice what I did. I mentioned ice, oak, and cork again, but I have the numbers. Now, some people might say, well, Mr. Rattoon, if I took this, and I don't really like writing paragraphs, what if I would put it in bullet form like this? And then I went and I made it like this, and then I did this, and would this be all right, Mr. Rattoon? Because this makes more sense to me. If you had it like that and that makes more sense to you, do it. So you're just organizing your data. You don't necessarily have to explain the data, but you have to have it here, and your explanation will be in the reasoning. That'll be tying it all together. Now, how do you get advanced? Again, you could mention the other ones. You could use more data, the ones that sync. But yet, if you go back to evidence, it says you don't have to have that. So if you do, that's probably what's going to push yours towards that advanced. And then the last thing is the hardest part, the reasoning. Now, when it comes to the reasoning, it shows how or why the data counts as evidence to support the claim. So it ties that evidence to the claim, and it explains, yeah, this is why my claim is correct. So it provides the justification for why this evidence is important to this claim. Now, one of the things you want to make sure you do is you include one or more scientific principles that are important to the claim and evidence. We will have scientific principles on most of our CERs. So you want to make sure you do that. If you don't, I'll tell you right now, it's going to be developing at best if you don't put in the scientific principles. So we've already gone through the scientific principles and we figured out it was number 3. Now keep that in mind. So here's my example of the reasoning for this. So the first thing you want to do, and over here you have the must-haves. These are the things you want to have in your CER reasoning. I'm always looking for 4 things. 1, you want to restate your claim. The material that would float if placed in water are ice, oak, and cork. Now notice where I got that from. I just copied and pasted it in there. Now I wanted to include my evidence, so I thought this was a really nice spot to put in my densities. So I didn't just say ice, oak, and cork. I said the materials that would float if placed in water are ice, 0.9 grams per cubic centimeter, oak, 0.6 grams per cubic centimeter, and cork, 0.1 gram per cubic centimeter. So that's my claim. Now, scientific principles. I have to have that. So if I back up again, and all I'm going to do is copy and paste this, and I'm going to put it right here. Now, one of the things I always suggest you do is say scientific principle number 3 states, and then here it is, word for word. But what this does, importantly, where it says scientific principle number 3 states, is it's kind of like a call sign that says, hey, teacher, look, here's the scientific principle, and it's number 3. Sometimes students will put it in there, but they'll reword it, it'll be vague, and I'm left trying to decide, did they put it in there, did they not? Whereas if you do something like this, and you can always shorten it to be SP, like SP number 3 states that. Well, that tells me for sure you know what it is, and it's boom, right there. Now, you do have to put it out there. You can't just say SP number 3 supports my claim and then move on. You have to put the scientific principle in there. Once you get done with that, this might be the most important part right here, number 3. You have to explain why this scientific principle supports this claim. Why? Well, here it is. Just one sentence. That's all I needed. All 3 objects that I chose have densities that are less than 1. So we know that if it's less than 1, it will float. How does that tie that to ice, oak, and quark? Well, all 3 of those objects have densities that are less than 1. And the last thing I'm looking for is some type of concluding statement that ties this all together. So I just wrote, therefore, the 3 substances mentioned above will all float if placed in water, because you want to know which ones would float. So that's the basics of the CER. Overly complicated? No, but yet you do need to be thorough. And the big mistake I usually see with the reasoning is I don't see a scientific principle, or people will try and just summarize this all in one sentence. Where if you're going to include these 3 parts, you really can't do it in one sentence. So if you ever have any questions about CERs, you want to talk about them more, or you want me to review some stuff with you, just please ask during class. I'll help you out whenever we have time. Thanks. Bye.